go through it. It is the same thing as we have done it for the t-test table. Now, the next and the last part of this unit is chi-square test. It is also said to be chi-square. Now, the main chi-square test, what it does is, when you get a data from a sample, like you construct a sampling distribution. What do I mean by a sampling distribution? For each of the sample, you are going to find the mean, standard deviation, and start grouping accordingly. The frequency that I get is said to be sampling distribution. Now, what the chi-square does is, when you get a data, no, it can fit a very good distribution such as binomial distribution, Poisson's distribution, normal distribution, all this distribution, it can fit in a very proper way, provided the data is being taken from a sample. Now, this, as I said, it will fit a proper distribution. So, when I talk about distribution, I'll have frequency. Now, with this chi-square, there are only two things that I need. Here, this is observed frequency and the expected frequency. EI stands for observed. So, OI stands for observed, EI stands for expected frequency. Okay. Now, once this has been done, so we define our chi-square to be summation of OI minus EI. I have told you what is this OI as well as EI whole square divided by EI, and this is with or for n minus 1 degrees of freedom. Now, again, the table also goes on the same line. You have, if the degree is of freedom is 6, if the degree of freedom is 6, what we do is, in the sixth row, check for T of 0.05. So it is 12.590. Similarly, for 0.01, it is 16.81. It is the same thing as we have done for, it is the same thing as we have done for your t-test. So the value here, if the degree of freedom is 4, and I need to find chi-square of 0.05, what I do is, in the fourth row, here, go for 0.05 column, you will find 9.490. So again, you start comparing the thing with your chi-square. If your chi-square value, same thing again holds. If it is less than your chi-square of alpha, less than it is, then accept the data. If chi-square is greater than chi-square of alpha, where alpha stands for the level of significance, level of significance means you have 5% and 1%. 5% is 0.05, 1% will be 0.01. If it is greater, rejected. Same argument that we have done for t-test, same thing is going to apply even for your chi-square test. To start with, first chi-square test or t-test, chi-square. Write down, chi-square is measure of correspondence between the observed and the expected. Is measure of correspondence between observed, between theory and observation. Now here, if OI is a set of observed frequency, and I can't directly write the formula. Before the formula, I should define what the notations are. Is observed frequencies, and EI is expected frequencies, then chi-square is defined as chi-square is equal to summation I is equal to 1 to n. N will be the size OI minus EI the whole square divided by EI for n minus 1 degrees of freedom. This is the formula for your chi-square test. Now, as I said you, it is a best chi-square test or chi-square test has test of goodness fit. Why I say it is a goodness fit? Because it enables us to fit a proper distribution, theoretical distribution such as binomial, Poisson's, normal, etc. The distribution which is obtained from your sample data. So chi-square test as a test of goodness of fit. Now the chi-square test enables us to ascertain how well the theoretical distribution, how well a theoretical distribution such as binomial, Poisson's, or normal, etc., fit empirical distribution. The meaning of empirical is nothing but the distribution which is obtained from sample. I'll mention even that also. Empirical distribution is nothing but that is distribution obtained from sample data. Now, this is all about your chi-square. If it is clear, shall we proceed with the example?
Yes, ma'am.
A die is thrown 264 times and the results of this are given below. Are given below. Number appeared on die. Next is frequency. So for 1, 40, 2, 32, 3, 28, 4, 58, 5, 54, 6, 60. Test whether the die is biased or not. Now, can anyone tell me what is the null hypothesis? Hello? Please answer me because in the previous class, I was just proceeding further with my class and I was disconnected for 15-20 minutes. This has happened. So please let me know. Reply for whatever I'm asking you. What should be the null hypothesis for this?
The die is biased.
No, question is what test whether the die is biased or not is the question. So what are you going to take?
Die is not biased.
Die is not biased. Is instead of not biased is unbiased. We use a word. Die is unbiased. Now, if you see this, is this yeah? See, when I say chi-square, what does this chi-square does? It is not interest. We are not interested in finding the mean, standard deviation, variance, nothing as such. We are just trying to fit a distribution. That's it. Nothing more or less we are doing. So for that we need only two concepts. One is observed, another one is expected. So what is given this 40, 32, 28, 58, 54, 60? What you can see, no, these are your observed frequency. Getting the point? These are observed. Why I'm saying observed? Because what does this say? A die is thrown 64 times. So one has appeared on a die 40 times. Two has appeared 32 times. Four has appeared 58 times. So this is all about the observed frequency that it is saying. Is this clear? Understanding what I'm trying to tell you? So after, is this my observed frequency? Do you agree with this now? Now I want to find the expected frequency. So what should be my expected frequency means I need to find it now. Expected frequency for the numbers, what are the numbers? 1, 2, 3, 4, 5, 6 will be for numbers 1, 2, 3, 4, 5, 6 is 264 divided by 6. Do you agree with that? Why I have divided? Because you are doing it for 6 number and it is thrown 264 times. So this is 44. Now what did I get now? So my observed and expected I have got now. What is my observed frequency? It is 40. See, these are the observed one. 40 and expected will remain the same. 32, 28, 44, 58, 44, 54, 44, 60, 44. Now what I do is after once I get this, as per the test of statistic is the test of statistics is chi-square is equal to summation I is from 1 to n. What is the value of my n? N is nothing but 6. N is there are 6 numbers. See 1, 2, 3, 4, 5, 6 here. So the value of n is 6. So that is OI minus EI whole square divided by EI. Now what will I get? It is 40 minus 44 whole square divided by 44 plus 32 minus, I am taking the difference square, minus 44 the whole square divided by 44, 28 minus 44 whole square plus 58 minus 44 whole square divided by 44, 54 minus 44 whole square divided by 44 plus 60 minus 44 whole square divided by 44. Now check what is the value for this. Calculate and tell me what should be the answer. Hmm. What is the answer? Hmm. Can you tell me? Hello? What is the total answer? It is 22 as per my calculation. Check. So what I do once I get the value, I have to compare. How will I say that it is accepted or rejected? Check what is chi-square of 0.05. With degrees of freedom is what this formula is for n minus 1 degrees of freedom. For n minus 1 means 6 minus 1 for 5 degrees of freedom. Formula is for 5 go in fifth row for 0.05 it is 11.070 for 5 degrees of freedom. Now what I say, therefore chi square is less than chi square of 0.05. So what is the conclusion I am saying? Therefore H naught is accepted. What was my, oh sorry, it is greater than, I have got 22, no? So chi-square is greater than this, so H naught is rejected. What was my null hypothesis? The die is unbiased. Now what should I write? Therefore, the die is biased. The die is biased. This is my conclusion. Is this clear? Hello?
Yes, ma'am.
Yes, ma'am.
Now, among 64 offspring springs of a certain cross between between pigs, 34 were red, 10 were black, and 20 were white. According to a genetic model, these numbers showed to be in proportion. These numbers showed to be in proportion 9 is to 3 is to 4 is the data consistent with the model of 5% level. Now, to start with, total there are 64 pigs. Now, that doesn't mean that the value of n is 64. Remember this. In chi-square as well as in t-test, we are not moving more than 30. Now, among 64 offspring of a certain cross pig, what is this? 34 were red, 10 were black, 20 were white. So this 34, 10, 20, these are nothing but my observed frequency. Out of 64, this is what we are saying. Getting out of 64, 34 are red, 10 are black, and 20 are white. Now, what we are going to do according to this genetic model, the numbers showed to be this is in this proportion. The number showed to be in this proportion means these pigs are taken in this proportion. Means 9 red, 3 black, 4 white are being taken. So given is 9 plus 3 plus 4. So we are taking, how many we are taking out of 64? We are taking 16 pigs are into consideration. And what is the given proportion? The given proportion is what? The given proportion is 9 is to 3 is to 4. The meaning of that is, see, this is a basic thing. 9 pigs were taken out of 16. How, how will you say 9 red pigs? Is this what you use? See, that is the meaning of the ratio. What I have written is 9 pigs out of 16. Out of 16 because the ratio is 16. No, why I am saying 16? Add all these things. Total is 16. So 9 pigs out of 16 are what I am saying red. Should be red actually. Should be red. Similarly, now how I will explain about this 3? 3 pigs out of 16 should be what? Black. Similarly, now for 4 pigs out of 16 should be white. But total are how many pigs? How many total pigs we have? Hello? How many total
64.
pigs? 64 we are having. This is the ratio that I have taken, no? We have to take the ratio in 9 is to 3 is to 4. So how will I calculate? Now whatever I am doing this, no, this is nothing but your expected frequency I am trying to find. Observed is already given 34, 10 and 20. It is already given. I am just trying to find what is my expected frequency. So for separately red, black, white, the complete problem is about finding the data is about what you have to take pics, and that too it is with respect to the color of the pics that you are going to consider. So therefore, how many pics there are total? Therefore, what I should write? Out of 64 pics, can you tell me what should be the answer? We have, can anyone tell me what should be this? 9 pics out of 16 is what? 9 divided by 16. Here, what does this mean? 3 by 16. Here, what this means? 4 divided by 16 or no? Now, I am saying there are total 64 pics means, therefore, 9 by 16 into 64. So, how much is this? 36. So, total, what I am saying? Total, there are 36 red pics. Now, in the same way, 3 by 16, why I am multiplying it by 64? Because total pics are 64. This will be 12 are black out of 4. So 4 by 16 into 64 is equal to what I say? This is 4, 16 white. For what I have got? What is my observed and what is my expected frequency that I have got? Observed frequency is 34, 10 and 20 because this is already given. 34, 10, 20. 34, 10 and 20. Now what did I get? Expected for red. This is for red, black and this is for white. Now expected for red, what did I calculate? It is 36. For black, it is 12. For white, it is 16. Now take the test. That is the test of statistics. Therefore, chi-square is summation OI minus EI whole square divided by EI, which is equal to 34 minus 36 whole square divided by 36 plus 10 minus 12 the whole square divided by 12 plus 20 minus 16 the whole square divided by 16. What is this now? 4 by 36, 4 by 12, 16 by 16. Check what is the answer of chi-square now. What is the answer? Is this 1.44? As it is 1.44, what I have to compare? I have to compare with 0.05 with degrees of freedom is for n minus 1 degrees of freedom. Can anyone tell me what is the value of n? What is the value of n? Hello? N value is 3. See, a 1, 2, 3. So N value is 3. So this is 3 minus 1 degrees of freedom, which is 2. For 2 degrees of freedom, what I have to do is, for 2, go into second row with 0.05, it is 5900, 5.990 for 2 degrees of freedom. Now, if I compare the two, therefore, chi square is less than chi square of 0.05. Therefore, H naught is accepted. I have not written H naught. Therefore, see what I'm writing as H naught is not written. Here you can mention that your null hypothesis is that genetic model is true. As I have not mentioned, I am simply saying that genetic model is accepted. It certain times it happens that you are unable to construct a null hypothesis. Actually, null hypothesis is required only, but in some cases, if you can't write, at least write what is the concluding part and end up. In such cases, if you are getting confused with null hypothesis, straight away write the conclusion and come. Even that is fine. Is the thing clear? Hello?
Yes, ma'am.
Yes, yes.
Okay. We are going for the next example then. Fit a Poisson's distribution for the following data. And test goodness of it. Given here, no need to go for the table because already it is given. Given chi square of 0.05 is 7.815 for 3 degrees of freedom. What does this imply? What does this say? What should be the value of n then?
4.
Yeah, value of n is 4. 15, 3, 2, 4, 1. Now, if you want, you write the null hypothesis, otherwise you can leave. Fit a Poisson's distribution. Now, this is the application of your chi-square. Fit a Poisson's distribution for the following data and test the goodness of fit. Now, what I say is, my null hypothesis is Poisson's distribution is a good fit. Poisson's distribution is good fit. To start with, now as it is Poisson's distribution, what we know, f of x is what? E raised to minus m. This is a formula or no? Hello? Is this the formula for your Poisson's distribution or no? F of x is equal to e raised to minus m into m raised to x factorial. Hello?
Yes, ma'am.
Now, if I see this formula, there is a term that I need to find. What is that? M. Now, how will I find the value of m using this data? Can anyone tell me? How will I find the value of m using this table? What should be the formula? Getting no, why I am finding mean? It is because it is required. If instead of Poisson, binomial was used, what was for binomial? Binomial is NCX P raised to X Q raised to n minus x. Now I need to find P and Q. How will I find P and Q? Again, I'll find M is equal to NP. N value will be given. Find the value of M using this. Once you get this, find the value of P. If you get the value of P, Q will be 1 minus P. This is how you have to relate the things. Just P and Q are not given, but a data is given. So I can find the value of M. N is what? At this point, N is your 4. So N value I have already got. N value is 4. M value, check. So if instead of Poisson, if binomial is given, you have to do it on the same line. Method will be the same, only formula is changed. In exam, don't expect that whatever I have done in the class, the same thing will appear. Don't expect that. Final exam I'm talking about. You have to understand the things. So e raised to minus m raised to x divided by x factorial. Now what I have is m value, how will I calculate? It is summation f into x divided by summation of f. This is my formula. So what I do? 0 into 122 plus 1 into 60 plus 2 into 15 plus 3 into 2 4 into 1 divided by 122 plus 60 plus 15 plus 2 plus 1. So what is summation of f now? This is 200, 0, 60, 30, 90, 90 plus 90, 100, 100 divided by 200. It is 1 by 2. 1 by 2 means zero point 0.5. M value is zero point 0.5. So what is my f of x? It is e raised to minus 0.5, zero point 0.5 raised to x divided by x factorial. Now, for n is equal to 200, what do I mean by n? Why did I take n? This is actually nothing but your summation of f. So, my capital F of x, what I am going to do is now finding the expected values. These are my observed values. Now I am finding the expected value means f of x. What is expected with Poisson's distribution? So it is n into f of x. What is that? It is 200 into e raised to minus zero point 0.5, 0.5 raised to x. Put this in your calci and tell me what do you get? Hmm. So f of 0, check what is f of 0 before that. Find this 200 into e raised to minus zero point 0.5 into zero point 0.5 raised to x x factorial. Now calculate it for 0. It is 200. Why I am finding it for 0? Because I am finding the expected value for 0. Then 1, 2, 3, 4. So for 0, check what is the answer? Minus zero point 0.5, zero point 0.5 raised to 0 divided by 0 factor. I have got the answer to be 121.3061. So it is approximately 121. Hello?
Yes, ma'am.
Ah, okay. Similarly, see, affix this in your calci and start calculating the thing for 0, 1, 2, 3, 4. Now, similarly, what is for f of 1?
60.65.
60.65. So 61, approximately 61. F of 2, check for f of 2. It is 15.16. So it is 15 only because 15.16 is the value. F of 3,
2.5.
for how much? 3, how much you are getting? 2.52 means it is nearly 3. Now F of 4, check for 4. Calculate for 4. It is 0.31. So it is approximately 0. Now what I do? Observed and the expected one. Observed is what? The one which is given. 122, 60, 15, 2, 1. 122, 60, 15, 2, and 1. Now what did I get for this? It is 121, 61, 15, 3, and 0. Now here for the last two columns the frequency is less than 5. So what we do is we can rewrite in this way. Observed, and this is my expected. 122, 121, 60, 61, only with frequency less than 5. Huh? Now I am just adding the 2. 2 plus 1, 3. 3 plus 0, 3. End. Clear? What did I do is I am just adding the two things. This is equal to 2 plus 1, and this is 3 plus 0 that I have taken. Now the test of statistic is chi-square. Chi-square is equal to summation OI minus EI whole square divided by EI for n minus 1 degrees of freedom. Now chi-square is equal to 122 minus 121 whole square divided by 121 plus 60 minus 61 whole square divided by 61 plus 15 minus 15 whole square divided by 15 plus 3 minus 3 whole square divided by 3. Now the second two parts, last two parts are 0. So chi-square is 1 by 21 plus 1 by 61. Check what is the answer. 121 plus 1 divided by 61. So is the answer, hello, is the answer 0.025246?
Yes, ma'am.
Now what will I do is compare what is chi-square of 0.05 for what degrees of freedom is. What is degree of freedom? Degree of freedom is 4. Here the value is already given 7.815. 7.815. Now what I do? Therefore, chi-square is less than chi-square of 0.05. What do I say if it is less than? H naught is accepted. What is the conclusion I should write? Therefore, Poisson's distribution is a good fit. Is a good fit. That's it. Is this clear? Hello?
Yes, ma'am.
One example from your end. Let's see at least an example. Whatever I have given now I am expecting. This was binomial. Now let's go with not Poisson's, binomial distribution.
Excuse me, ma'am.
Yeah, tell me please.
Ma'am, scroll a bit up.
Wait a minute. Huh. Is there a doubt?
No, ma'am, no, got it.
Okay, so next example we'll go ahead with. This example I don't think so I can solve it, but let's see whether you can understand and solve it. Coins are tossed 100 times. and the following results are obtained. And the following results are obtained. Fit a binomial distribution, underline the word, fit a binomial distribution for the data and test the goodness fit, test the fitness of fit. Given is given chi-square of 0.05 is 4.49 for 4 degrees of freedom, and number of heads frequency. As 4 is the degree of freedom, so what does that mean? Hello?
Five numbers of head.
Actually, see, the this has to be 3. There is some mistake. Let's check out. It is not degrees of freedom has to be 3, not 4. There is some mistake in the problem only. 2, you will come to know. Just see. 3, 25, and 4 is 5. So what should be the value of n according to you? What is the value of n? N is 5. Is that right or no? Agree? Hello?
Yes, ma'am.
Yes,
But
ma'am.
actually 1, 2, 3, 4, 5. It is taken in this way. For chi-square, it is the number of tables it has been. Yeah. For chi-square test, we are taking 1, 2, 3, 4. But when you are going with binomial distribution, no, remember one thing. Binomial distribution, these are the number of heads means for binomial distribution, n is equal to 4 only. Remember that. And when you are taking this chi-square test, no, here the summation I is equal to 1 to n is 1, 2, 3, 4. That is the value of n. Binomial will tell 0. Number of heads means 400 times the coins. See, to start with, as it is already 50. I'll just tell you how to find for binomial only the outline of the sub problem. NCX P raised to X Q raised to N minus X. Now, if you read the question, coin is tossed 100 times and the following results are obtained. Same thing as your Poisson's distribution. Now, what you have to do is p value is to be found. So, find the value of m first. Why m? Because m is equal to np and this value of n is 4. Remember that you can't take it as 5 because here you are dealing with binomial distribution. The total number is important. Now, once this has been done, find the value of m. How you find the value of m? That is summation f of x divided by summation of f. You have the value of m, n, you will find the value of p. Once you get the value of p, find the value of q as 1 minus p. Once all the value is done, substitute here. As it is tossed, how many times it is being tossed? How many times it is being tossed? Hello?
100 times.
So what I have to do, capital F of x is equal to 100 into your f of x. Now what you get, find it for 0, 1, 2, 3, 4. Once you get all the values, now your expected and your observed frequency. Clear, no? You are finding it for 0, then 1, 2, 3, 4. Find all the values. Then OI and EI. What is the value for 0? You write. So 1 for 0. This is for 1, 2, 3, and 4. So the value of n will be what? 1, 2, 3, 4, 5. So n value is equal to 5 at this point. N for chi-square, it is, we are not dealing with anything. We are just dealing with the observed and expected frequency. So if I've said that N is the size of the sample, I'm sorry, it's not so. Here we are not dealing with anything as such. We are just trying to fit a distribution. Clear? I am expecting the answer from your end. In the next class, you are going to tell me, are we accepting it or rejecting it? That's it. If you are accepting, write that Poisson distribution is a best fit. If you are rejecting, it is not a best fit. That's it. Is this clear? Hello? Hello?
Yes, ma'am.
You can write. You can write your USN numbers and you can leave.